Hello, everyone. Welcome to this week's episode of the Days Hero podcast. I'm Spectre. With me is Z. Before we get into our topics today, we do have a bit of a correction for a topic that we covered last week, and that was on the Windows telephony service exploit. So, for those of you who tuned into that discussion, you may recall we were speculating for a bit. We're a bit confused on how they dealt with ASLR, and we actually received an email from somebody. So, to that person, thank you very much for sending us an email and clarifying it. A lot of our confusion there came because Z and I don't really do active Windows research, but on Windows, the ASLR on like the services and the DLLs is on a per boot basis. So from the process that they already had control over, they could kind of just already get that module base address and they didn't have to worry about it. So that's why it wasn't really talked about in the post, is because it was trivial to get around there. So just wanted to add a bit of that correction because we did spend a little while talking about it last week. But yeah,
Yeah,
that clarified
that's
that.
that's one of those things that like every time I do come back on Windows, especially anything like local, because that is the other thing. Obviously, if you're doing a remote exploit, you don't have access to know that. It is kind of specific to local exploits, so privilege escalations where you're able to take advantage of that fact. And it's one of those things that I've learned and I forget like every time between actually going back on Windows or not.
Yeah, yeah. The context and stuff can easy to get mixed up. So yeah, just wanted to shout that out. And once again, thanks to the person who sent that email. So with that out of the way, we can get into some of our topics. The first of which is pretty interesting. It's from Kim Zetter on Zero Day, zetter0day.com. And it's about the fact that the US government has disclosed that they reported 39 zero-day vulnerabilities in 2023 to vendors. And this is actually the first time that the US government has reported the numbers. So for a while, there's been this board called the Vulnerabilities Equities Process, or VEP. Now, I hadn't even heard of this or known that this existed. And
Yeah, and I'm not sure if I did either. They kind of call out that during Heartbleed, it was first when it kind of was announced to the public, and I when they mentioned that, I vaguely remember maybe having heard about it then around like the Heartbleed stuff, and then promptly, another thing to just forget when it doesn't matter. Obviously, without them putting out much information, there's not much to talk about either. Just this process exists.
yeah, and I thought that process was kind of interesting. So the whole idea behind that process is it's basically used to determine whether or not zero days discovered by government agencies should be kept secret or disclosed. In the past, the government has commented saying that in the little bit of information they have given out, they've said that about 90% or more than 90% of vulnerabilities that go through the VEP review do get disclosed. But there's been no actual numbers given on how many bugs have gone through that process until now, with a little bit of these numbers. So we still don't know like the total that went through or the number that were kept secret or anything like that. But it was stated that 39 vulns were disclosed, 10 of which had been through the process previously, which means that they had been up for review before, and they do like a yearly review. So when vulnerabilities go through this VEP process, if they are decided to be kept secret, they don't think there's a need to disclose to the vendor, whether it's because they don't feel like the impact is high enough, or it's not generally exploitable enough, or it hasn't been exploited in the wild. They revisit disclosing it the next year. So if it had been through the process before, that means, it had been decided to be kept secret and then was eventually disclosed at some point down the line. So yeah, it's kind of interesting. It seems like the veil of secrecy, I guess, is being lifted a teeny tiny bit. There's still a lot of information that's not been talked about,
Yeah,
but it
this
is
is
sort of a, where it's the first of its kind report, it is sort of a milestone.
Yeah, it's interesting to see. And the number 39 vulnerabilities disclosed, it's not the number I expected, but I don't have like a good grounding on what I should have expected.
I was
Um,
gonna ask, like, do you expect more, or like
I
were you expecting a higher number?
so I part of the problem is like what exactly these vulnerabilities are, because on one hand, if this is just like of all the vulnerabilities that the government ever deals with, then 39 feels really low. Like how many vulnerabilities are they finding? Are we giving them credit for way too many vulnerabilities? Or is there kind of a loophole going on here where vulnerabilities that are coming out of contractors who maybe provide the exploits without explicitly providing the vulnerability information, if that might be kind of the loophole where it's like, well, they're using these, of course. They're, it's pretty clear that the government does buy exploits. And so maybe there's a loophole around, well, it's not the vulnerability, they're buying the exploit. And, unless they reverse engineer it or something, like, unless they do a bit more work, they don't have the vuln. So, maybe it's different on that front. Because, yeah, 39 in a sense feels low, but also feels high to be like the government's actually disclosing like nearly 40 vulnerabilities. Like that's also kind of high. If these are like, Apple or Android O days.
Like high value targets.
Yeah. So it kind of comes down to what exactly this is. And just to know, when it does come to contractors, they do call out that like contractors are included here. The board reviews vulnerabilities discovered by US government, by contractors working for the government, or foreign partner governments that share vulnerabilities with the US. So I do wonder if vulnerabilities is maybe doing some heavy lifting on that and giving kind of that loophole. The other thing is, if this ends up being like, if they buy them, then maybe they don't have the IP rights to disclose or whatever, like something on that front. And therefore, like, this is still kind of left to things that are government directed, like the contractors were directed to do this research on like a target. And that's kind of comes into an interesting over what targets and vulnerability research do those internal to the government do compared with those working for the contractors, because we know the contractors hire like the browser researchers, Android, iOS, and generally like a lot of people go that route and not into the government because the contractors tend to be able to pay more, provide better work experience, and all of that. And so, then what's left for the government to actually be the responsible ones for? And I think of like with Stuxnet, obviously the government had SCADA exploits, and there isn't as much demand in terms of trying to buy SCADA exploits or anything like that. So that feels like the place that
I mean,
perhaps...
we don't know for sure, to be fair. Like our visibility into the market is, it's hard to make judgments like that, but it's hard to imagine there's a market for that where it's so specialized. Generally, like the market that a lot of the money is in like generic things that can hit a lot of devices. So that's kind of like the rationale of why you would think that stuff like the SCADA stuff would probably be done internal.
Yeah, I mean, there probably could be some contractors too that are directed onto it, I could imagine. But yeah, it just kind of comes down to, like, I feel like there's all the flashy browser exploits that probably are done through research outside, or at least a lot of it is. Whether or not the government also is doing a lot internally, we also don't really know. But yeah, it gives me the feeling like, are these vulnerabilities like of that variety?
Of that caliber,
yeah. Where it's like, okay, well, this impacts our power grid or our systems, therefore we're going to disclose. This impacts an enemy or whatever, so it does, like, we're not going to disclose, because that is something they talk about, is like whether or not it poses a risk to US critical infrastructure or the general public. So that could also be kind of an area. But yeah, I don't know, it's interesting. We have, like you just said, we have like no insight into what the actual research is, what the vulnerabilities are, so it is purely speculation on my side. It's just like, if these are like high value O days being disclosed, which I kind of doubt, then like 40 is a high, 39 is a high number and more than I would have expected. On the other hand, like, it's the entire US government. So like 40 is also just like, at that scale, feels like they should have more, like, of anything. So yeah, it raises some questions for me, but it just kind of comes down to the fact that we have no information here. Like, the unclassified document, I've just pulled it up here, is literally like a third of a page long. Like, it's very short. It doesn't really say much, just, here's the numbers.
I will say with the US government, what a very interesting point is because you kind of have these agencies that are in the intelligence apparatus and then like everybody else, there has been reports in the past of agencies sort of clashing with each other, where like one agency in the government, for example, is completely unaware of a vulnerability that gets exploited in the wild, where somebody like an intelligence agency had that information and was actively exploiting it and kind of covering it up and not talking about it. And there was some animosity between like those two branches of government. So like the US government as a whole, like holistically, is very large, but it's a few select ones that are engaging in a lot of like the vuln research and exploit development in that way. It's not fully cohesive, it seems, across all the branches either. Um, and yeah, so like you'd kind of talked about the fact that they want to protect U.S. infrastructure if they feel like there is a threat. That is the VEP board specifically feels there is a threat. Then they'll disclose to vendors, and we've kind of seen examples of that in the past. So again, like it's really hard to make these judgments because there's so much veil of secrecy around it, by design, of course. And that's kind of what the whole intent of this report is that this report was declassified by Senator
Wyden.
Senator Wyden, and he's kind of been pushing for increased transparency into the process of like vulns and how they're being used by government and how that process works. And it's kind of interesting because I can't really recall a time before where there was like someone in a high position of government that was pushing for that. It's always kind of been either just not really understood because, a lot of people in US government, especially senators, are like old and not super tech savvy. So it's kind of an area that they don't really have great visibility into to begin with. Or there's like active efforts to not have it being talked about. So it's sort of interesting seeing that shift. Again, at least at this point, it's a very minor shift. It's still very like actually useful information. Um, but yeah, I mean, it shows a bit of a willingness from at least some parts of government to offer that transparency, which is something that's been wanted by some parties for a very long time. We're talking like over 15 years at this point.
Yeah, well,
Another,
we were just talking about it the other week where we were talking about like government operations with exploits and stuff. And I know during that I had mentioned like, I do think we need more like oversight and transparency into what's actually going on. So, I
yeah,
mean, sure, I'm Canadian, so this technically doesn't give me any insight for what's going on over here. But still, it is process. Like, I do appreciate the attempt here to at least have something out there because it is interesting information. This information doesn't tell us a lot, but like the information in this could be very informative when it comes to like what the government is doing. That I think
yeah.
like the government needs to, be held accountable in general. So anyway, I kind of interrupted your statement there, so carry on.
No worries. I was just going to go into two quotes that I thought were kind of interesting, beyond the raw numbers. So one of them was a quote by Michael Daniel. He was a former cybersecurity advisor to President Obama. He was quoted saying, so NSA, National Security Agency, was doing its own review of vulnerabilities that it found following the policy internally, but it wasn't being surfaced all the way up to the National Security Council level. And there wasn't a robust process at the NSC level to really get the whole process working and all the agencies involved. So that's another thing where like, even with this 39 number, like that's the number that made it to the vulnerabilities equities process review. That doesn't necessarily mean that all of the things that are being used by like the NSA, for example, are making it there. So again, you kind of have those like levels of indirection where it gets even more complicated with trying to get any insight into the numbers. And then the final quote, which is kind of, I guess, wrapping up the premise of the article, is they had talked to Masuri's. I don't know if I'm saying that properly. If I'm not, I apologize. She's been pretty prominent in the like bone research space and like the government and 0 day space for a long time. She was a former lead senior security strategist at Microsoft, but she had said even if the vendors themselves would have a hard time gauging relative risk, how is the federal government supposed to assess that risk? And again, that's something we've kind of talked about where it's hard to really gauge impact, especially if it's not actively being used in the wild and you don't have hard data to look at. Trying to do that risk assessment on behalf of like everybody else in the tech space is kind of difficult to do, honestly, because the U.S. government and like NSA in particular have this whole mantra of nobody but us capabilities, where they feel as long as they have a vulnerability that they feel other actors can't reasonably expect to exploit or be able to use effectively at scale or something, then they're fine with keeping it secret. And it's like, okay, on principle, you can kind of see the justification for that, but it does mean that you have to have a lot of trust in your like risk assessment. And as Masuri's claims here, like if the companies that are overseeing their own software are having a hard time gauging the impact, it's hard to imagine, you know, government being able to do that better somehow.
I
So
I
yeah,
agree and disagree actually on that point.
I mean, there are different angles. Like the government should, I guess, have a better aspect of or like ability to judge how easy it is to weaponize, whereas the companies probably don't have as good of a focus on that, where,
So my
they're just
thinking,
focused on fixing the bugs, but I don't know.
yes, my thinking is actually more on the fact that when the government's doing it, they're not assessing the risk for any individual of like this exploit is going to hit this place. I imagine their assessment of risk is going to be a lot wider. Is this product even being used across the US? Like, is this common to see? And asking like these very big questions rather than being able to focus. So it does come down to how this risk assessment is being done in the first place. But just as the government, I could imagine because they don't need to get as bogged down in the weeds, it could be easier. It could also be harder because then they're abstracting everything. It's like, it doesn't hit this percentage number, then it's not a risk or something. Like it could also go on that route too, but I could imagine a reason why it could be perhaps easier to reason about because you don't have to worry about the specifics as much. But that is purely where I'm coming at it from. Like, as soon as you go into them trying to do any sort of specifics, then I entirely agree. Like, the actual, in a sense, risk assessment would be very difficult for them to pull off, or for them to actually do, because they just don't have the insight into all the private companies and such. But you make a fair point regarding the weaponization aspect. But yeah, we also don't have any information on how the risk is assessed. So
But yeah, all that's to say, like, we still don't know a lot. It's fun to speculate, and it is interesting seeing a bit of that shift. That said, the blog post is somewhat pessimistic on the future of that and going more towards transparency, because they have this direct quote where this lack of transparency could become a greater issue under the Trump administration, which has vowed to ramp up the government's cyber offensive operations. Um, and there is kind of I'm not going to go too much into the politics, we try not to do that on this show, but there is kind of evidence of Trump doing this with other things, like I remember the CDC, some of the CDC data, a lot of like data sets that the government provided have been getting culled and removed under the Trump administration. So it seems like, as a whole, government is moving towards more opacity, not transparency. So that could very well be the case with like 0 days and stuff too. So this might be like a one-off year where we get a number and then we never get it again or something. I don't know.
yeah, in
Um,
fairness, it sounds like this was a one-off year before too. So it just exists as its own special year where we get to know.
yeah, we still don't have a lot of visibility into like how big the 0 day stockpile is or anything like that. But I mean, it's rare that we even get anything to talk about at all from U.S. government on this topic. They've historically, famously, been very quiet on it. So, um, yeah, this blog post was a very interesting and fun read, despite the fact that we don't have a ton of new information.
Yeah, I appreciate the post. I'm not sure how many other places talked about it, but this I thought was a good post.
Yeah. But yeah, unless you have any more to say on that, Z, we can get into some of our vulnerabilities, I guess.
Oh, I think we can move on.
Okay, so our first post here is by Nordy, and it's on what Okta's Bcrypt incident can teach us about designing better APIs. I thought we had talked about this on the podcast, but I'm not sure. I'm pretty sure we've talked about this sort of issue before, but I will let Z get into the details.
Yeah, and we have absolutely talked about the speed crypt issue before because this is like the single most common gotcha about using bcrypt. I don't know if we actually talked about it in terms of the Okta incident, and kind of the vulnerability being there, but they kind of address it here along with some thoughts. They actually dig into something that I actually learned now too. But starting off with the issue, Bcrypt is kind of a hashing algorithm, and it was used for a little while as like a recommendation in terms of password storage because it in the era, we've kind of had the shift where it's like storing passwords in plain text, and then oh well, let's hash the passwords with MD5, so you can't just reverse it easily. But well, you can calculate MD5s very quickly, so rainbow tables came about where people would generate everything, then you could just like do a big search of if in the rainbow table for the hash that you needed. And then people started salting the hashes. Then people could just brute force that once they had the salt and could kind of do the calculations very quickly. And so Bcrypt kind of came about as trying to introduce more CPU cycles into the process to make it computationally intensive to calculate the hash. And so if you want to do this at scale, you would need like a very powerful CPU. But then, we get people building specialized hardware, can kind of like get very good speed just by
You have
basically
your
doing it all
ASICs
in
and
hardware.
stuff. Yeah.
Yeah. And so that's where we now have things like Scrypt and Argon 2, where they also introduce more like memory requirements, making it harder to do at scale again. And I'm sure in the future there's going to be something else where we need to make it more difficult to scale. Anyway, so we've had kind of that progress going on. So Bcrypt, existed. It was a recommendation for a while, but because of its history, it comes out of Blowfish, and Blowfish, it was cool. Kind of, it still exists. It's an encryption algorithm, and the key thing about it is it has a variable key size. So normally, when we talk about a lot of crypto system, they work on blocks. Even a lot of stream ciphers will kind of underlying. They'll be generating blocks of data that get encrypted, or they'll have a block they regenerate as they hit the end, or whatever. But and with that, they tend to have this key size that is related to the block size they're encrypting. So they have a key that's 128 bits or whatever, and then they can encrypt the data like in chunks of the same size. And so Blowfish, being a variable key size, was kind of unique and different in that. Variable key size, you can give it a key of any size that you want to. Well, not quite any size. There was a limit in the initial creation of it was limited to, I want to say, I see the number 72 pointing up here. In my head I was saying 75 is a limit. So yeah, it had a limit where basically after that point adding a larger key just wouldn't have any impact. It had a limit in Blowfish. And so when people start trying to create hashing algorithms that were trying to be a bit more secure, they've already done some research on like making sure the outputs here are randomized and stuff with encryption. So hashing, kind of makes sense to use these encryption algorithms. Today, you don't tend to see it as much, and that's just because encryption algorithms have a different threat model in a sense. Like they have different concerns, of course, and so you don't see too many new ones coming up there based on existing encryptions. Like think the last one that comes to mind for me was like Whirlpool. I don't even remember when that came about. That's based on AES. There's probably
That was
others.
from yeah, it was described in 2000.
Yeah, I mean, well, I think even the Bcrypt is. I'm not sure how old Bcrypt is. Presented in 1999, like right around the same time. So, like, that was kind of what people were doing, is they were adopting the encryption. And to be clear, I don't know the meta when it comes to all the crypto development. I have a little bit of a history with Blowfish, so I know a little bit there. Anyway, so you had Bcrypt. They're using Blowfish, and they're kind of using like the key system in order to encrypt that or use the encryption, but turn it into kind of a hash. So they use the key system, and so they end up borrowing this same idea of there being a 70-ish character limit on the key, which then became in the very first implementation of Bcrypt uh, the limit on the hash data. And so anything after that would just be truncated to uh 70 whatever characters. So, and the example here seems to be about 72. In my head, I swear it was 75, so maybe it is 72, but whatever. That, in general, if you're just hashing a password, like, it means, if somebody has a 80 character password, you only need to brute force the first, 72 characters. Frankly, that's not a massive deal to me. Like, that, you've got a lot of security already at that size, and if you go too
It's
long,
not a practical security issue. Yeah.
yeah, like maybe in the future it would be, but right now, it's less. But then you also have this case now where in Okta's case, they were using the Bcrypt algorithm to generate a cache key where they would combine the user ID, username, and password, and using that to create the cache key that would be used. And so they have the password, which maybe is long, maybe not, but they have the user ID, which is like a UUID or whatever, so it has a little bit of length, plus the username, which can be kind of long, leading to part of the password actually being truncated. And so you could, in theory, have a very long username. Let's say all that takes up 70 characters. You only need to brute force 2 characters of the password, and that's where you start having issues with Bcrypt. Is when you try and include other information in there, you can end up having, technically speaking, if you just have a long password, you have an issue with Bcrypt. But when you're able to have other arbitrary length data in there too, that I think is one of the bigger places where I've seen this gotcha creep up, as was the case with Okta here, where you could basically have no password actually being checked, just as long as your username's right, assuming it's a long username, you're good. Anybody can log in. And so that's kind of where the issue came. I was actually surprised. I didn't realize that the author here decided to take a look at, well, what are modern implementations doing? And turns out Golang will actually give you an error if you try and use too many characters. It'll just be like, nope, you're using too much. I don't care what you're trying to do. You can't do this. Rust has an option. They have a no truncate and truncate option. And they kind of just work through. So I was pleasantly surprised to see these errors. Some of these languages have chosen to introduce an error or make it clear. I do actually appreciate seeing that. I think that is a good step. You're laughing, Spectre, so do you have something to call out here?
I just found it funny because you said you were pleasantly surprised at languages, but I kind of thought the opposite. It seems like Golang's official Bcrypt library was the only one that really did it well. Because so they go through some of these different languages. Go is what they start with. When they get to Java's Spring security project for Bcrypt, does not check the length for the input. It just allows an arbitrary length input. The a separate library by Patrick Faber did check the length. Getting into JavaScript, the JavaScript one doesn't check it. Rust, they looked at it. They say that it doesn't really check the input length. That said, reading the code, it looks like it does. So do you have some of the
there's another route in there. Basically, it's another call, and they admit up there they used AI to write some of the code here. Got help with that, I believe it was. Did they call it out?
They mentioned that they use Claude AI to write the code.
Yeah. I knew they had it somewhere in there. Yeah. So basically, the AI generated the code using the other path. But yes, there is an option that it'll give you an error on truncation. So it becomes an option that you can do, and that's the thing. Part of what they talk in their kind of concluding area where they have some good API design suggestions, they talk about this in the context of not having an ego in designing your API, and users need to read the paper. That's just stupid users doing this. And when it comes to Golang, when making this sort of change, the problem is intercompatibility or interoperability really matters with hashes. If I hash something on one system, I expect that when I hash that same thing on another system, it's going to give me the same hash. And so if you have, something that truncates and then something crashes because like Go just didn't do it or it panicked or something, like that's a
You
very
have
different
differentials.
behavior. Yeah,
Yeah.
you just have this weird situation where one it works in one place and not the other. And so that I think is why now pretty much everything on Bcrypt actually does the truncation, even though it technically isn't necessary, like by spec isn't necessary sort of deal. But like everything has done it because it always has. And like that exists inside of
Yeah.
crypto. And
Well, a big part of that is because they mentioned the fact that a lot of Bcrypt stuff is done following the OpenBSD implementation, which decided to truncate it. BSD kind of has this funny thing where you might not see it on a lot of systems, especially nowadays, but it has a lot of history in driving different projects. You have BSD stuff implemented in Mac OS. You have some of it even there's even some crossover with like Linux and like other applications. A lot of stuff from BSD ended up making its way into other projects. And you kind of have that problem where any problems that open like BSD's implementation had is going to carry over into other things too. So that seems like that's kind of why that like de facto standardization of truncating the input happened, is because of the OpenBSD implementation.
yeah, I think just in general in crypto consistency is expected. So like OpenBSD was kind of one of the first early implementations, therefore it got followed. Like it's not
Yeah.
like yes, the influence of OpenBSD can't be denied too, but also being first, like in this case, kind of like being very early mattered. I don't know if it was first exactly, but
Yeah.
uh
It was the one that people went with for the reference implementation.
yeah. Yeah, so when it comes to some of their recommendations about API design, in general, I do agree with them on things like not having an ego where it's like, well, they need to read the paper before. Like, I agree to an extent. I do feel like crypto is actually the exception on this. And hopefully, like, when you're writing code, you just shouldn't actually be calling into Bcrypt. You shouldn't be calling into AES. There's this old post from oh, why can't I remember his name now? Travis Potachek, I think. I can't remember his name right now, but anyway, he had this post about you shouldn't be writing AES. Unfortunately, it's been taken off the internet, so I don't actually have a link for you guys anymore. But it was basically just kind of showcasing how like basically unless you really understand all the crypto issues, even trying to deal with the algorithms directly, like you should preferably defer that to somebody more experienced. So use libraries like libsodium where instead of giving you here's how you call bcrypt or here's how you call scrypt, it just gives you like pw hash, and you can configure it to use a specific algorithm, but it also just has the default option where it's just like use the default algorithm. And when it comes to crypto, like I want a secret box, I don't want the algorithm. Let somebody more experienced actually determine what type of settings you need, and then you just have
Well,
the better API.
to
Although
be
you do
fair,
have challenges on interoperability. Go ahead.
that's exactly what
Yeah.
I was going to bring up is that in theory, like that's great. Like, yeah, don't allow people to configure the crypto system if they don't fully understand all the parameters. But yeah, you do have that issue of if you have multiple components interacting, you kind of have to know what the configuration is.
Although
Um,
ideally, if you're in control of those components, then you can just be like use the same setup of the higher level library, like the password hash or whatever.
if possible.
Yeah,
Yeah.
like you should be going that way. Like as soon as you start dealing with the actual crypto systems, you can have these very subtle and nuanced bugs. And yeah, it's just crypto does feel like one of those special areas where it's not enough, I think, to just make it dumb, like make it easy for anybody to use. But in general, I agree. Like we talked about this kind of related to crypto, but I think it was a PGP API. This is quite a while back, where we were talking about like they just had this really misusable API, and of course that misuse actually led to some issues. Um, and like that should be avoided. they call out here like be helpful. Like if you have some that doesn't accept certain inputs, just return an error. Let people know like you provide invalid input. And I totally agree. Like a lot of this had Bcrypt just tossed an error and had everything kind of copy that, would have been in a way better place from the get-go. If they just did that instead of doing things silently and expecting people to understand how to use. So like largely I agree. It's just I kind of want to have that caveat on do read the paper before you're dealing with crypto, or work with other people who know a lot of the crypto, because it's just so easy to have mistakes in crypto. Even when
Yeah.
you're using things like there's no way to do it right necessarily. It's just your choices have consequences that might be okay in some cases and not in others, might not interoperate with like another system quite as well, whatever. But there's a lot that can happen. So that's the one caveat I have. But otherwise, like I largely agree here.
Yeah, and I guess kind of the other problem with crypto is it has sort of a similar thing to law, where it's like once it's out there and it's kind of set, you can't change it afterwards with how it's going to work because of what you said, where you have to have that expectation of an input matching the same output on different machines with the same configuration. Like you just can't go back in time and change that, right? One of the thoughts that I thought was pretty interesting though was the let me just bring up the exact thing. Yeah, so the Be Brave section. Uh, so the common thing you always hear in crypto, and we've kind of talked about it a lot before too, is the don't roll your own crypto. If there's an implementation out there and it's being catered by professionals and everything, use that. They're going to be able to implement the algorithms better than you can in pretty much like every case. But this section sort of challenges that in that it's sort of a good thing with like the Go team and Patrick's Java library that they decided to implement it and go a different way than kind of the rest of the industry did. And it you could see it as sort of a positive where, it does do that loud error. It doesn't do the silent truncation. That is probably the lesser of two evils. And the only reason that those are able to handle that in a better way is because they went a different direction and decided to do it, themselves. Now, that being said, I think for the most part, like don't roll your own crypto still applies. Like these, like the Go team, for example, I kind of trust to be able to write crypto libraries. It's not like just some random person, but still, it is sort of an interesting point where, having different implementations can be nice for dealing with some of those shortcomings that you find in a lot of other places.
Yeah, and when I talk about not rolling your own crypto, like the exception always there is obviously somebody needs to write the crypto. So it's working with those who have the appropriate knowledge.
Yeah.
Maybe that is you. Like I'm sure some people listening do have that deeper knowledge and could actually get. And when you have that knowledge, you can make the choice to, in a sense, be brave and make that change, like with Golang. Yeah, I think that's fair. It's not like nobody ever should write any crypto code and nothing should progress. It's just
Yeah. I guess I use the don't roll your own crypto, but really I guess the one I was trying to attack was the don't reinvent the wheel concept. If people hadn't reinvented the wheel, so to speak, and done a different implementation,
oh,
yeah.
on that front, if you're interested in that wheel, reinvent it all you want.
Yeah.
That is the thing. Like a lot of things come out that's, and I've talked about this actually when it comes to how I think adoption of languages like Rust will happen. I think it is going to be people reinventing the wheel. It's going to be people who create their own like pseudo alternative, who create like those tools. I think actually reinventing the wheel is one. It's really just important for learning. You just for your own exploration, but like on one sense I am kind of there for don't reinvent, like don't waste time. But if you're motivated to do so, like I don't necessarily think it's a bad thing.
Yeah.
As long as you're motivated, interested in it. Yeah.
Yeah, and I think that point in the blog post is kind of a good supporter of that. So I thought it was a bit interesting. Thought I'd call it out. But yeah, crypto issues are always fun to talk about, and because of like all the implications and like silent failures you can have happen, it makes it ripe for causing security problems. So, like you said, the Bcrypt stuff is nothing new. It is kind of a common gotcha, but it was fun seeing a bit of a survey of how it's handled across different languages and libraries.
Yeah,
I
it was
haven't really seen
actually
that done, so
Yeah, that was actually the thing I learned of this up at the start of the topic. I mentioned how I learned a thing of, and yeah, I didn't realize Golang, through the air that there were options that were even doing that today. So that was kind of the thing I learned out of it. Yeah, it was nice to see that approach and taking a look at what things were doing.
yeah. Getting into our next topic, PortSwigger has put out their top 10 web hacking techniques for the year of 2024. So we tend to cover these. I think we've covered the last, like, at least the last two or three of them. Sometimes they have some overlap with things that we talked about on the show. Sometimes there's stuff that we missed, especially because it seems like a lot of the web research, especially in 2024, came out while we were on our break. So that's just kind of how that went. But yeah, so we like to cover these when they come up. Z went through and kind of took a look at all of them and has a lot of the technical details. So I'll let Z get into the list.
Yeah, and I feel like at least half of these did come out while we were on break, either during our summer break or this year in particular. We recorded an episode early for our winter break, then left a little bit earlier than might have been expected. And so also a few things kind of came out late in the year that made it onto this list. But yeah, there's unfortunately this year it does feel like we missed quite a few, and it has given me a little bit of pause in terms of taking a look at our process for deciding on topics and why I initially maybe because some of these I did see and then didn't look into. I just assumed I knew roughly how it worked and assumed it was this sort of write off, whereas it actually did have some nuance. Number eight actually kind of has that issue. So wait until we get to that one. Go all clickbaiting. Number eight will shock you. But yeah, I'll just run through the top 10 here. We've got hijacking OAuth flaws via cookie tossing. Cookie tossing is just that idea where like a subdomain can set cookies on the parent domain. And so if you have like attacker controlled content on the child domain, like an XSS there or something, you might be able to get a cookie set, which then takes advantage or can then take advantage of being set on the parent domain. And in fact, what they end up doing on this was hijacking OAuth flow by setting a cookie to the parent domain and then specifically on like the callback address and on one of the other API endpoints. So basically, it would use the attacker session cookie instead of the victim's actual cookies during those specific points. So the website looks like everything's working fine, but when they try to connect an account over OAuth, it would actually connect to the victim's account or would connect the victim's account to theirs or whatever because uh the wrong session was being used. So I thought that was actually an interesting take there. When I saw the cookie tossing, my mind initially just went to like that pretty old attack that you haven't seen a lot of uses for. So it is kind of cool to see it be used here. ChatGPT account takeover with wildcard web cache deception. I believe we talked about this, and basically just came down to the cache or the CDN wouldn't do URL decoding versus the server, of course, would. So they made a request that looked like it was going to one path, but had a path traversal in it, but URL encoded. Therefore, the server would serve content that shouldn't be cached, thinking it's a request there. And CDN thought it should be cached, and so they got the sensitive information cached. Number eight, the shocking one, OAuth non-happy path to account takeover. This one, a lot of these OAuth bugs really just have to be like find an open redirect and use that with it. And so I kind of scanned this one, saw it's using redirects, and this is one that I saw and didn't cover, and I missed the nuance too. And the nuance on this one was that the application they're targeting would redirect based off of the refer header. And so they actually had to do a little bit of research on being able to go through the OAuth flow. So when it comes back, getting the code in the fragment. So if you're unfamiliar, if you do a server-side redirect, the fragment part of the URL will remain the same through that redirect, whereas client-side redirect usually will just strip all of that or remove all of that. So if they can get the server-side redirect to happen, by having that refer header set to like the attacker's website, when it comes back, it sees like, oh, the refer here is, this, so let's redirect to that website, the correct website for them to be on or whatever. does the redirect there and keeps the fragment. And so if they get through the OAuth flow with that using like prompt equals none, so if they've already been through the flow, it won't I guess the detail I'm also missing here is in how the referrer header gets passed along. So through server redirects, as the referrer header also doesn't change. So the attacker can open a site with their referrer header and then kind of get to work through. It's a cool post. Do give it a read. I missed that nuance, which is why we didn't end up covering it. Arbitrary number 7 here, arbitrary JavaScript execution, PDF.js. PDF.js is what Firefox uses to render PDFs in the browser. It's also actually what we tend to use when we show PDFs on here. I kind of load up an instance of PDF.js to show it. So, even if you haven't used it, you've probably seen it when we have PDFs, although not this episode. When I had a PDF up earlier, actually was using Chrome's default on that, but oftentimes
Taking precautions, I see. Saw it in the top 10 list. We were like, not using it anymore.
Nope, I'll still use it, but it was just a little bit easier today not to. Anyway, it's actually kind of a cool bug. I just didn't see this one. I'm not sure if this was a summer one or what it was, but it had to do with glyphs, and basically it would try and elf the PDF, you had a font in there, whatever, has glyphs, and it would try and turn that into JavaScript for more performance instead of doing all the, because fonts and glyphs just there's so many, they're very often used with like memory corruption bugs. You're able to get issues in there because it's just very complicated. Anyway, so it's trying to convert it to JavaScript, and in doing so, there actually was a way of getting arbitrary JavaScript injected into it through the font matrix. It would just like copy whatever's in the font matrix so they could copy in arbitrary JavaScript instead of proper content. So kind of a cool attack. Definitely, they call it out here as being an overlooked attack surface. Yeah, cool attack, cool read. So double click jacking here, number 6. I saw this over the winter break, and I don't know, it kind of double click jacking is already a term that exists for the same attack. Um, they do something novel here, which makes different, like double click jack. Just the idea of a click jack where you would abuse the fact that there's a little gap between first and second click when you double click. So you get that mouse down at the first click, make your change to the UI before the second click happened, and then get the second click to land on your attack. Like, that isn't exactly a new idea. What happened here is basically they, instead of using frames, as I understand it, they use basically pop-ups or like have the interaction, and because they have an interaction, they can make use of other windows here, and they just swap out the windows to get you to click on something else, which also means that this is a new navigation, so it won't, or same site doesn't have the same impact on it. And of course, it's not a frame, so X frame options won't do anything. So it is a really simple thing that basically led to bypassing the existing, and like is a way of still doing clickjacking despite a lot of protection. So it is cool. Like there's something cool on that front. Just like the fact that double clickjacking is already an existing term, and now if you try and look that up, you will only come across this. Unfortunately, I even tried doing a date lookup, and because so many websites do their dates wrongly and like maybe have a sidebar or something, you'll have like, oh yeah, here's a 2003 post about this 2024 presentation. So yeah, I couldn't find too many resources on that, but yeah, this came out during our winter break. I think it actually was on our schedule to cover, and then we just had a lot going on because it was coming back after a break that I didn't have a lot to say. And it honestly, that one, because that one also got like media coverage, not like mainstream media, but like it was very well covered. I feel like people also saw it. So anyway, dump purify library, bypass fixes. This actually dove into several things. More than just one vulnerability, so I can't just summarize it for you, but it is just a good resource on I mean, dump purify technically, but MXSS in general. I've kind of been meaning to actually do an episode where I just talk about like a bunch of MXSS issues. I have like a scheduled thing for that, and we just haven't got on it, but this was one of the topics I had added into there too. Worst fit is cool. It actually has an impact beyond web. So this is the web hacking. This is number 4, web hacking. It deals with character set conversions where Windows would try and convert between or two ANSI characters from maybe UTF uh, or Unicode, would do that translation. Basically deals with that, where you can end up having basically different characters, where you might have like various symbols in there, and then it's actually there's an example here where it has like the square root symbol, pi, and then I don't even know some of these symbols. They have a few symbols there, and translates to VP7 equals 8, which looks like, a very normal string that can end up coming out of this translation just happening kind of unexpectedly. And so it actually has impact on like desktop, where just like getting an environment variable could run through this, or getting the command line could end up running through this. And so it has a wider impact. Of course, servers such will use these same functions, so has the web hack impact, but it has a wider impact than just web hacking. And of course, there's also the question of who's at fault over this. This is one case where curl got the bug report and decided, nope, this is a Windows fault. Whereas Windows, when they ported curl and have a curl.exe, they actually fixed the bug, but the original curl did not. When decided, like, basically passing around the blame. So yeah, it is pretty cool to give it a read and understand. TE.0 HTTP request smuggling. I think we talked about this at some point, but it wasn't as its own topic, although I couldn't actually find where we did. This is one of those things that, or maybe it came up as a side effect of talking about PortSwigger post. But yeah, it's request smuggling. This one's transfer encoding 0, so it was one that as mentioned in the post. No, I being the author here, hypothesized that transfer encoding 0 could exist, but that would never be exploitable. Of course, somebody did find it and did find a case of it being exploitable, so it's a fun read. Definitely check it out. SQL injection isn't dead. Smuggling at the protocol level, smuggling queries at the protocol level. This was a DEF CON talk that I definitely talked about when we were kind of covering DEF CON talks and interesting ones here, but yeah, it ends up
Wasn't its own dedicated topic, but yeah.
Yeah, like we talked about it, it was there, but we covered it at that point. And it was one of my favorite talks from DEF CON, so definitely deserves to be here. And then confusion attacks in the top 3 here. Or sorry, I guess that's top 4. Worst fit was from Orange, I think. Let me double check that. Yeah.
It was, yeah.
It was from Orange, as is number 1 here. Confusion attacks exploiting hidden semantic ambiguity in Apache HTTP server. It is also from Orange, and came out during the summer, so wasn't one that we got through. But again, so it's going like on different confusions or different in semantic confusion. So it starts off with the question of like, if you have this rule in your Apache server, like what files are going to access, and like it actually accesses like I think in the example case, like it accesses 2 different files, and like has some unexpected behavior. Good read, pretty deep. Yeah, I mean, on the whole, like definitely worth being number 1 here. I don't really disagree with anything here. In some prior years I've had some disagreements, but this year I don't really have a lot to say like on the meta level. That's why I just kind of spent most of our time here talking through what each of these were if you want to check them out, but there's nothing here that isn't worth at least giving a read.
Yeah, and I find it kind of interesting. They state that this was a very intense competition for the panel and the voting to decide on. There was not only a lot of research, but there was a lot of high quality research that came out in 2024. So, it's kind of cool. And I feel like we kind of observed and noted that too, that it seemed like novel web research seems to be on the upward trend, where it seemed a little bit stagnant for a while. But yeah, in like the 2020s, it seems like COVID and like the the research system for that just kept going up and up for discovering new things. So yeah, it's been very interesting looking into the web space and seeing kind of the stuff that's been coming out of that.
Yeah, and there's been a lot of interesting takes of like reusing older, overlooked attacks, like with
Yeah.
double click jacking, the one I called out there, or the cookie tossing. Like, there's been a lot of that, and that's just generally going on with like parser differentials and stuff too. Uh, yeah, web research is, I think, one of the like kind of fastest growing areas when it comes to security research.
Yeah. But with that being said, our next two topics kind of move away from web and more to the binary side. So we have a post by Connor McGarr that talks about exploit development, investigating kernel mode shadow stacks on Windows. So this doesn't really get into a vulnerability per se. It's more of a reverse engineering and research post. But it talks about shadow stacks on Windows. So this is a front end for Intel's CET. That's control flow enforcement technology. CET includes both indirect branch tracking for the forward edge as well as shadow stack for backwards edge protection. Windows doesn't use IBT. It instead uses their own control flow guard, which we've talked about pretty recently, actually. But yeah, so the whole idea with shadow stack is it's designed to kill techniques like ROP. So you have your typical stack, you have your stack variables and your return addresses. And in a typical case, if you have memory corruption, you have the ability to smash the stack, you smash the return address to hijack code execution and run a chain of gadgets. But in the case of Shadow Stack, a read-only copy is kept of the stack, and the red instruction will compare the return address on the stack with the one from the shadow stack. And if it doesn't match, it'll throw a CPU exception. So Connor McGarr wanted to see exactly how this is implemented in Windows. He kind of looks at it from two angles, being the NT kernel perspective and the secure kernel perspective. And that's kind of what I found interesting, is that the secure kernel is involved in this process. So I started looking into thread creation code in the kernel, and yeah, Windows has some interplay with the shadow stacks and the secure kernel, or VTL1, at least for the kernel thread stacks. So in Windows, for those who aren't aware of what I'm talking about with VTLs, with Windows, you have kind of your classic x86 ring permission system. You have your ring 3 for user mode, ring 0 for kernel. But you also have VTLs in modern versions, or virtual trust levels, which are enforced by the hypervisor and HVCI. So your main operating system, most of your applications that are running are going to be running in VTL 0, which is like the least privileged trust level. And then the higher VTLs, like VTL 1, are more privileged. The secure kernel, for example, runs on VTL 1. Technically, VTL supports like 16 different levels, but in practice, at least right now, I think only VTL 0 and VTL 1 are used. So yeah, looking into the thread creation API, the shadow stacks are created and mapped into VTL1, where after some of the initial setup, a call is made to change the permissions on those pages for the shadow stack so that the secure kernel kind of has like the read write access to it, and VTL0 has read only. And it seems that as part of Intel CET, there's a new flag that was added into page table entries, bit 60, which I believe was a reserved bit. It kind of had to have been. But yeah, if you set bit 60, it sets it as like a shadow stack page. And they use a secure call to basically get bit 60 set in the extended page table entries for VTL 0. That said, sometimes the shadow stacks do need some legitimate modifications. They call out exceptions as an example. So there is an API for that too. You can call into the secure kernel to restore and validate the shadow stack context. But yeah, I found it pretty interesting. They're using the secure kernel to protect the shadow stacks in that way. Because if they had just done like a typical uh have these two separate areas, it gets mapped as read only in the guest kernel, but uh if you had an arbitrary read write primitive as an attacker, you could go into the page tables and change that. I think it still would have been a reasonable mitigation, because you're still trying to prevent the ROP at the time of the function pointer hijack. And in cases where you don't already have like some arbitrary write primitive, that would still be pretty strong at preventing ROP. But it seems Microsoft has kind of gone that extra mile and integrated the hypervisor of enforced code integrity into that process to make it so even if you have a stronger attack primitive, you can't just get access into the shadow stack to allow your ROP to work. And I thought that was pretty interesting. It's kind of cool that they're leveraging the secure kernel to do that. I guess I should have expected it, but seeing all the technical ways that they managed to get that to work are pretty interesting, and it seems kind of strong. I was kind of theorizing as I was reading through this how you'd be able to break this, and maybe, you know, again, assuming you had a kernel read write primitive, if you were able to get around this and drop easily. And I don't think there'd be a great way to do it. I think your better way would be going after the control flow guard. I think the control flow guard is a lot weaker on the forward edge than shadow stacks are on the backward edge, which typically it's kind of the other way around in a lot of targets. So yeah, I thought that was pretty interesting. Obviously, there was a
Oh,
lot of detail that I glossed over. This is a very long blog post that goes into all of the uh control flow that makes it work. And I can't really cover all of that on the podcast, but I would recommend checking it out if shadow stacks and forward and backward edge protection are interesting to you. Sorry, go ahead, Z.
yeah, I was just gonna say, when it comes to forward or backward edge and it being stronger, I've always felt like I guess the opposite, that forward edge was generally the stronger side, then not implemented as often. Or maybe that's what you were kind of getting at, whereas um
That's what I was saying. Yeah, typically the forward edge, like hijacking function pointers or something, that's received a lot more attention for trying to mitigate it. You have like CFI and Clang-based CFI from software. You have Intel's IBT tracking at the hardware level. I believe AMD has something, but I can't recall what it's called off the
I
top of my
think it's
head.
still coming. I'm not sure if it's
Yeah,
actually
I don't think
landing
it's
yet.
actually released. Yeah.
Every time we talk about CET, we mention that it's
Yeah.
coming, but
Yeah, it's like a it's a hope and a prayer. But yeah, so like at least on the software side, like the forward edge has been focused a lot more, and the uh return addresses and roping has always been something that's a lot harder to actually address, at least in a way that doesn't murder performance. Because you're talking about something that is going to be invoked on like every single call, or it's going to have an impact on every single function call. So
yeah,
it's
and
something that
that's
needs to be performant, and you kind of need that hardware backing to make it work well, and that's still pretty new. So
yeah, that is kind of a key thing because it's not like shadow stacks are a new idea. Like I remember talking about shadow stacks back in like 2009 or something. Like it's been known as like an option for a long time, but like I said, key thing is performant, and that has only really been the case with CET having support for it, having the hardware level support for it. I think Cherry has something with that too. Has some support for it, but we don't really see a lot of Cherry devices.
yeah, um, yeah, and we are talking about like x86 specifically here.
Yeah.
You do get some nuances when you get to other architectures, but yeah, so it's kind of a newer thing, and seeing how Windows has done it is very interesting. It was a little bit surprising to me how well thought out and well implemented it seems to be. Now again, like I don't really do a lot of Windows research, so I am kind of going off of what was covered in this blog post. But from what I saw, it seems like a smart way to implement it.
And
And
the
like I
choice
said, if I
too.
was personally attacking, I would just go after the CFG because where it's so like coarse grained, it would be a lot easier to do something useful going that way, I think.
Yeah, the choice to use secure kernel is definitely an interesting one there. Makes sense with Windows kind of starting to push and with Windows 11 requiring the hardware support for some of this lower level security functionality. And we've seen, I think they have the hypervisor available now, even on, like, you can't use Hyper-V, without Pro, but I think it's
But
available.
HVCI
So,
is on all editions.
yeah.
Yeah.
So with that, they're now taking advantage of that fact, and ultimately, I think it is good for security.
Yeah, for sure. It's a very smart move. And the whole like VTL concept that they have going on, they're able to do a lot of things that they couldn't before necessarily because of that virtualization. Because another thing, for example, this is kind of outside of the scope of this blog post, but I figured I'd go on a brief tangent about it. Hardware. So things like the IOMMU and devices being able to just like DMA over memory is something that's always kind of been a problem with Windows. It's hard to deal with properly because Windows is such an open ecosystem, so to speak, compared to like say Mac OS, right? Where with Mac you're only able to have whatever devices that Apple allows to be supported, really, at least on like PCIe and stuff like that. So they're able to take some liberties with how they lock down the system, where Windows kind of has to support a lot of different vendors. But because of their virtual trust levels and being able to use a secure kernel, they can lock off a lot of the more sensitive things into the secure kernel, which is then isolated from the untrusted and potentially compromised guests because of, the Hyper-V HVCI stuff they have going on. So yeah, it's a good move, and this just seems to be one more thing that HVCI can provide. So yeah, it's pretty cool. And like I said, there's a ton of detail and information in here. And that's particularly useful for Windows because of the fact that it's, undocumented. It's not open source. So a fair amount of this is like reversed and stepping through with debugger. But that's also, can make it very useful if it's something you want to look at in Windows. Uh, there's a lot of useful information there for you. So we have that for Windows. We also have a Linux-based topic. So this is a vulnerability. This was accidentally uncovering a 7 years old bug in the Linux kernel by LL Security. So it starts off with talking about a syscaller, sysbot report that kind of tipped them off to a problem. The report was a ref count addition on 0 use after free that was reported in TCP TWSK unique. Initially, they were triggering this through the KCM protocol, kernel connection multiplexer, but after testing and digging into it more, they found they could actually trigger it without KCM. It was actually in the TCP core. Turned out a commit from December of 2017 introduced a bug. So the code before in this relevant area, it was related to the time wait TCP socket creation. So like it would create the object, initialize it, save the reference to a table, set the reference count, and then it would release a lock. It would do everything under a lock. Well, this particular commit that was introduced, do you have it up, C? Or I can pull it up if.
Yeah, if you know exactly which code segment it was.
Oh yeah, here's the commit that added the problem. Yeah. So for those of you who have like the video up and you can see that in this inet TWSK hashdance function, for example, this problem existed in two different functions. It was also in TCP time wait, but the ref count set call was moved outside of the lock, and it was moved to after the unlock. So that opened up this race condition where you had a window where the object was in the hash table. It could be looked up, but the reference count wasn't initialized and there was no ownership of the object. So in the case of the crash, this TWSK unique function was trying to obtain a reference on the object using the sock hold API, but that reference count wasn't initialized, hence the ref count increment on 0 warning. This so after that, they get into like information on how exploitable this could potentially be. They state that they think it could be exploitable because while the specific flow isn't very useful and just triggers the warning, like the Linux kernel has a warning statement where if you try to increment a ref count on 0, it will throw a warning saying like this is not typical behavior. This probably indicates some kind of use after free. So like that's going to happen regardless. And that specific warning isn't very useful. But there is a potential scenario where this could create a real use after free because the reference count being initialized after something else grabs a reference to it would lead to the ref count being one less than it should be, right? Or however many less than it should be, depending on how many things grabbed the reference before it was initialized. So you could potentially cause a use after free that you could exploit later on down the line. Now, you would still have to deal with the warn. And if panic on warn is set, for example, in the kernel parameters, I don't think this would be exploitable. I don't really see a good way around the ref count zero check and the ref count increment function in the kernel. But still, it's a pretty interesting bug with like how it got introduced and everything. It's very weird and suspicious seeing a reference count operation like that being moved outside of a lock, especially because the comment that's right above it kind of references the fact that the lock is sort of important. But yeah, for whatever reason, it got moved out of the lock and it created this race condition that could be exploited in the TCP system, which obviously the impact there is sort of high because having a Linux system that doesn't have TCP support is probably not going to be very useful. It's sort of a generic attack surface that's something you don't generally want bugs in for the security of your system. So,
Yeah,
yeah,
bugs in the TCP stack are definitely desirable and valuable bugs. In general, though, with this bug, like this is also kind of a generic case of storing something for access by others before it's actually ready to be accessed.
yeah,
And
that
that's
is a
just a
bad design
bug.
pattern. Yeah.
Yeah, and that's just the type of bug, it's happened a bunch in the Linux kernel, but it happens in multi-threaded applications in general, where there'll be like some tracking system that, as in the process of initializing it, people are like, oh, well, first we got to add it to this list, and then let's blah, 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 instead of doing that last. Oh, yeah, it's one of those patterns to keep an eye out for. And you can have bugs with that related to that, even if it's not memory corruption. Like that bug pattern is very common in like any sort of system that uh has concurrency going on and isn't distinctly uh or what's the term, embarrassingly parallel, like isn't like every step is independent. Like it is a common pattern to look for.
Yeah. And something else I kind of liked about this post is that it came from a syscaller report that it kind of shows off that difficulty you can have in triaging and root causing, where the syscaller splat had like the KCM part in it, and they thought that that was relevant, and they kind of had to dig into it a bit more to find out that the bug was kind of somewhere else. Again, like sort of a common problem in kernel and trying to debug like kernel crashes. Um, but not something you always see called out in that way. So I kind of like that aspect to it too. Um,
Yeah, it's a challenge. I mean, triaging crashes in general can be such a challenge because the crash isn't necessarily.
it's
Well,
not
I mean
necessarily
it.
the root cause. It can just be a consequence. Yeah.
Yeah, like the crashes, they might happen because of the bug, but oftentimes they are the side effects, and you kind of need to track down the rest of it.
Yeah. But yeah, so that's all the topics that we have for this episode. So unless you have any last minute thoughts, see, we'll wrap it up there.
Nope, no, no shout outs.
All right. So as always, we thank all of you for tuning in, and we will catch you next week.